module 14. This is now earthworks and volumes. So for earthwork and volumes, these are part of the surveying processes that we need to understand. How many volumes of soils should we fill in a specific location, or should we cut off or excavate on a specific location, either to identify a specific settlement, or to excavate a depth of soil for your foundation, or to excavate a particular depth of soil for your retaining wall, and different types of structure. So basically, earthwork is an important aspect for roadway design in determining the amount of earthwork necessary in a project, or on a project. So hindi lang yan for horizontal projects or roadway projects. Pwede rin po yan when it comes to your vertical projects, as well as for your superstructures like your bridges. Okay, so basically excavation, excavation, embankment of soil, and so forth and so long. Then earthwork includes the excavation of existing earth material in a replacement of fill and material required or for constructing the embankment. So pag sinabi nating embankment, ito yung transferred soil from a specific location that will then be placed on a specific location. So patataasin natin yung elevation ng section na yon, and there we'll be placing a structure or a roadway. Then, iba rin naman ang embankment pag sinabi nating cut or yung excavation. So, the manual method of determining Earth's excavation and embankment amounts involves 3 steps, which is your cross-section of the proposed highway or place in the original ground cross-sections, the areas and cut, and then areas and fill are calculated. So, yung meron tayong cut and fill. So, yung cut, ito yung embanked soil. Cut, ito yung excavated soil. So, calculated, and the volumes between the sections, again, are computed. So, pag sinabi naman kasi nating earthworks of cut and fill, hindi po eksakto yung geometric section na ida-dissect natin or i-bank natin or excavate natin sa isang location. So, we will divide it into multiple section. Okay? But sometimes kung halimbawa ang excavation natin is for irrigation channel. So for irrigation channels, syempre either trapezoidal yan or concave. So meron tayong regular geometric shape. Then we could easily calculate the section or cross-sectional area of that, as well as the excavation requirement, and as well as the embankment kung kailangan ng embankment. Then pwede rin yan when it comes to concrete embankment or concrete plasterings. Depende dun sa thickness at depende dun sa volume. And cut and fill are the terms that are usually used for the areas of the section. The terms excavation and embankment generally refers to the volume. So, pag sinabi nating volume of a soil, we'll then have to determine the amount of soil that we're going to embank on that location, or the amount of soil that we're going to excavate for us to start any type of construction procedure. So, for instance, sa foundation, ganito yung depth, ganito yung thickness ng foundation na kailangan natin sa isang project. And as engineers, later on, you'll be specifying the depth of the excavation needed for that particular foundation, whether it is a single foundation, a single square foundation, a mat foundation, a combined foundation, and so forth and so long. Ganun din for retaining walls, for roadways. So, pag sinabi naman natin sa roadway, kagaya dito sa Baguio, mga mountainous terrain, ano yung section ng anong yung section ng soil na ito para hindi siya mag-backfill or magkaroon ng soil stability failure. Kaya halos magkakasama lagi yan, si roadway engineer at saka si soil engineer. Si soil engineer yung mag-a-assess ng earth pressure or yung kanyang soil stability. Si roadway engineer naman yung mag-specify ng gusto niyang section para paglagyan ng horizontal roadway. Then after that, we'll have to specify the safe value of excavation of soil, or excavated or embankment of soil, to either tawag na dito, to either remove, or tawag na dito, to take safety of the soil stability. Okay? Pag soil stability kasi, pag sobrang steep yung ginawa mong excavation, more or less due to earth's pressure, excessive saturations, excessive rainfall, tapos kakainin ng tubig yung magsisip ngayon yung tubig sa lupa, hindi na niya kayang i-carry due to excessive load of water and excessive pressure, then it will cause landfall. Okay? Then, yun yung usually nangyayari dito sa Baguio. Kasi sobrang dami na ng chipping off na nangyayari. Ngayon, paulit-ulit na rin siyang nangyayari dahil hindi na soil stable, or hindi na stable yung slope ng ating soil. So, we'll have to specify those later on. But for now, we'll go over with the earthworks and volumes muna. These are some figures that we will be dealing when it comes to earthworks. So earthworks or volumes needs the following specs requirements, using end areas, end area volumes, barrow pit volumes, mass diagrams, and cost estimates. For the mass diagrams, nandyan na po yung para sa module 15, which is your howling. The mass diagram kasi is for us to identify the amount of volume of soil for us to excavate from this location, and the amount of soil for us to embank on this location coming from the excavation site. So from the excavation site, kukuha tayo ng volume of soil, then that volume of soil will then be embanked to the embank section. Basically, malapit lang. So yun yung mass diagram natin. And cost estimate of earthworks. Kaya napapansin niyo sa mga material estimates or bill of materials, unang-una sa ating listahan ng bill of materials is yung ating tawag na dito, earthworks. Kung vertical yan, earthworks for the foundation and excavation. Then, tawag nito, foundation staking or location staking. Pag location staking, yung mga markings natin, for us to start the excavation marks. For the tie beams, for the foundations, for the ano pa ba? For the tawag na dito, for the excavation, for the waistline, for the culverts, and so forth and so long. Example of which is as shown. So ito yung ating example excavation for foundations. So for foundation, single foundation lang yan, square foundation. Ngayon, as engineers, na-design natin yung kailangan nating foundation. Let's just say it is a square foundation. Ngayon, specify mo doon sa tawag na dito sa field kung gaano kalalim yung excavation for that foundation. Okay, so for this, ito yung depth, more or less. Ito yung thickness ng foundation, nasa 1.5 to 2 meters yan. Thickness of the foundation are around 0.75 to 100 0.75 to 1 meter, depending on the soil bearing capacity needed. Then dimension, more or less, that are adult, it is a 2 by 2 meters, and depende na rin yun sa design later on. Ngayon, ang i-compute mo na lang dyan is volume of soil to be excavated. And if necessary, saan mo ililipat yung excavated soil. Pwede mong ibalik yan for compression, or you can use that again to embank as part of the structure aesthetic. Okay. Now for the area cross section under earthworks and volume, we have level cross section and 3-level cross section. This is how are we going to subdivide a specific excavation section or excavated section. For your level cross section, more or less, that is trapezoidal. Pag trapezoid, anong area ng trapezoid? Ganyan lang naman yan. Trapezoid, 1/2 2D plus W. times C. Then 3-level cross-section. Pag 3-level cross-section, we can then subdivide it into multiple triangles such as shown. Multiple regular triangles. Pero meron pa tayong ibang method later on. Now, for the volume computations, there are 3 volume computations. So for volume computation, we have first is your end area method. For end area method, basically we will subdivide the uh, basically we will compute the area of the left, the starting and the ending section of a specific excavation site. Kunin natin yung front at saka yung back section. Okay? Then yung length of excavation. That is just your end area. It is assumed that the volume between the successive cross sections is the average of their areas multiplied by the distance between them. So end area nung front, then area nung front section and area nung back section, then times the length of excavation all over 2. Volume by Prismoidal method. Prismoidal method, area nung front, area nung middle, and area nung back section. Okay? So, tawag na dito, AM is your area middle, is determined by averaging the corresponding linear dimensions of the end sections and not by averaging the end areas of A1 and A2. So, pag sinabing area middle, kukunin natin yung area ng mismong middle section within throughout the length of the excavation, but not averaging of A1 and A2. Okay? Then, prismoidal correction. So, for prismoidal correction, the correction needed is the volume, ang tawag na dito, the correction is the volume of end area method minus the volume of prismoidal method. Okay? Then, IVP, yeah, minus prismoidal method. Or, the correction should be done by the length all over 12 times B1 minus B2 times H1 minus H2. So, ito naman yung V sub C, ito yung correction needed. Then, minus lang natin yan sa volume ni end area or volume ni prismoidal. Okay? I'll be giving multiple series of example on this lecture, so makinig na lang po ng mabuti.